press the bell icon on the YouTube app and never miss another update.
Hello viewers, welcome to today's session. Today we want to discuss about a fundamental proof of a trigonometry, that is d dx of tan x is equals to sec square x by using main formula, that is main rule or basic rule. So before going to the solutions, we just want to write down the formula, that is main formula. Here I am writing. Okay, proof. We have what we have the main formula. So it is d dx of f of x is equals to limit a tends to 0 f of x plus a minus f of x divided by a. This is our main formula. And now to establish this one here by using this formula, we have to get f of x and f of x plus a by using this given clue. Here the f of x is this tan x because of this is given, and we have to establish this one. So we can write down here f of x is equals to tan x, and f of x plus a I have to find out by using this one. So we can write down f of x plus a. Here we are replacing x by using x plus a. That's why here this x have to replace by using x plus a. Here f of x plus a is present. Just put these two expression in this formula. Then we can write down d dx of tan x because of f of x is equals to tan x. Here we have put here it tan x, and then limit a tends to 0. In replacement of f of x plus a, here tan x plus a minus f of x, that is tan x divided by 8. After that we know d dx of tan x is equals to here a tends to 0, tan x is equals to sine divided by cos. So we can write down sine x plus 8 divided by cos x plus 8 minus sine x divided by cos x. This is I have written in this pattern. This is actual pattern. We can write down by using this pattern, no problem, because of this is 1 divided by a. Actually I have taken it in this format. Now the next line is d dx of tan x is equals to limit a tends to 0, 1 divided by a is LCM. What is the LCM here? Cos x plus a and cos x. So I'm writing cos x plus a and cos x as LCM, and then we have to divide this expression by this one first. Then we will take cos x, and by using this cos x we have to multiply it sin x plus a. Then it will be sin x plus a cos x minus this minus, and then we need to divide this expression by cos x. Then we will get cos x plus a, and by this cos x plus a we have to multiply sin x. Then it will be cos x plus a sin x. Okay, then the new line will be d dx of tan x is equals to limit a tends to 0, 1 divided by a. Here sin a cos b minus cos a sin b. If we think x plus a is a and this x is b, then this will be a formula. What is this formula? I am just writing it for the betterment of you. Look here, sin a cos B minus cos A sin B can be written in the form sin A minus B. Okay, so if we think x plus a is equals to A and x is equals to B, then this is become this formula. So you can write sin A means x plus a is minus B means x, and the remaining things here cos x plus a is cos x. Now dx of tan x is equals to limit a tends to 0, 1 divided by a. This x and this x is cancelled, so it is sin a, and the remaining cos x plus a is cos x. Now we can write down ddx of tan x is equals to limit a tends to 0, sin a is divided by a is, and 1 divided by cos x plus a is cos x. Because of here 1 divided by a is present, I am writing 1 into sin a is equals to sin a is divided by this a is, and the remaining portion is here. The new line is ddx of tan x is equals to limit a tends to 0, sin a is divided by a is, limit a tends to 0, 1 divided by cos x plus a is cos x. Now here this is a formula, this representing 1, so ddx of tan x is equals to 1 into this one, so this term only. So limit a tends to 0, 1 divided by cos x plus a is cos x. After that ddx of tan x is equals to, we have to put here the value of the a, then it will be cos x into cos x. Then ddx of tan x is equals to 1 divided by cos square x. Here we can finally write down ddx of tan x is equals to, since 1 by cos is equals to sec, therefore 1 by cos square is equals to, of course, sec square x. This is our desired proof. If you think this video is helpful to you, then please subscribe my channel, like this video, share it to your friends, and stay with us. Thank you very much.
Press the bell icon on the YouTube app and never miss another update.